Okay, so here we go for the second review for the final exam. Okay, as usual, we put a little header here. M108, spring 21, final exam, review, and this is B. Okay, so now we were in the middle of doing number 5. We did 5A. Let me just show you what happened in 5A. We had a picture of the normal curve, right? I think I did it better last time, but anyway, whatever. So our first problem in A was to shade to the left of O5, of not O5, of negative 0.5, and not O5, negative 0.5 or negative 0.5. All right, so what we showed last time that there was a couple things going up here, 0.1, 0.2, etc., but that was really not important. What was important was this is, there was a hash mark, then a 1, hash mark, then a 2, not a negative one I meant, then a negative 2, hash mark, and then a negative 3. That's to the left. To the right was a hash mark and a positive 1, hash mark, positive 2, hash mark, positive 3. This signifies negative 0.5. This is positive 0.5, 1.5, 2.5, negative 1.5, negative 2, negative 2.5. That's what we explained last time. All right, and we had to shade. So so what happens? We use the icons that we explained on that previous video. We had something drop down like this, and then you click and it shades. Alex does most of the work for you, and it got all shaded in. Okay, here comes B. Very important, B. Use table. It's not necessarily complicated, but it's very important. Use table. They're gonna have their own table. The table is going to be the z-score table with the areas. Let me explain. Just give me a chance. Use table. I discussed this already in class probably, but I'm discussing on the videos, on this review video as well. Use table to get area, the area left of that same negative 0.5. Okay, so what do we mean by a table? The table, you click on table, you click on Alex's table, you click on the word table, and then this whole thing with all these z-scores and these areas drop down for you. There's negative ones and there's positive ones. Their table is going to have negative ones. There's going to have a bunch of negative ones, negative, 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 and they're going to have a bunch of positive ones, and it's going to be a long table with lots of values in there. And then there's going to be a bunch of positive ones, etc., and their areas, etc. Okay, so you go look for the z-score that says negative 0.50. You scroll down until you find it. Negative 0.50. Look across the way, and it should say 0.3085. Well, that value is everything left of the z-score, negative 50. So this one is a pretty easy problem. It automatically tells you the area of the next to the z-score is the entire area to the left of negative 0.5. Here is negative 0.5, negative 0.5, and the z-score is the entire area left. So what's the answer to this? The answer to B is not negative, 0.3085. There's the answer to B. Answer. That's how it works. Okay, so 5B is 5A we did in the previous video. 5B is our first one up on this video. Let's continue. I think I have actually enough room. Why not? Why not use it? Because I have a small problem to take care of. Problem number 6. It's quite small. Might as well use the space. 6. Okay, coordinates off. And number 6 is a pretty straightforward problem. Let's say a person gets $144 for 12 hours of work. 12 hours work. Okay. How much for 7 hours? How much for actually less? how much would they get for 7 hours? Okay, here we go. Answer. Let me show you how to do it, and let's go to the answer. 7 is to 12, right? We know what 12 hours is, so but we're looking for 7. 7 hours to 12 hours is equal to 144. Where do I put the 144? Do I put it on top or on the bottom? I put it on the bottom next across the way from the 12. 12 hours gets 144. I want to know how much a person will get for 7 hours, so that's the x. That's what we're missing. Now, cross multiply again. Another cross multiplication again. And you get 12x equals 7 times 144. And eventually, you'll see that that turns out to be $84. For 7 hours work, they'll get $84. That is the answer to problem number 6. Okay, this paper is done. Let's get rid of it. Let's get a new one. And let's go to problem number 7. Problem number 7 is where I'm going to go to, tell you to go somewhere else to go look for a problem exactly like it. It's going to be asking for an equation of a line, and it's going to want the x-intercept, the y-intercept, and to graph. And we've done this before. Let me show you where to go see it. Go to exam 3, review number A, problem number 4. Go there, you'll see a problem just like this. Problem number 8. Problem number 8. A problem that involves the set language. If you have 5 in a set, and then you have this thing, this sign there, this symbol, and right next door to it, you have 5 and comma 6, and it's going to ask true and false questions or something like that. So we've seen, and there'll be a bunch of them, etc. So we've seen this before. The C exam number, go to exam 2. Let me get this, make sure this is clear. Go to exam 2, review C, problem number 6. Problem number 6 to get something that looks pretty much like a problem, very, very similar, but very much like problem number 8. So that will be good practice for problem number 8. Problem number 9. This one let's actually do together. No, I take it back. We don't have to do it together. I'm going to point a place for you to look through it. Let's say that I'm going to show you a little bit more about it, what it sort of looks like. You've got an A, B, so you got 3 balloons in there, A, B, and C. With the box is the universal set as usual, and there's something in almost in every one of them, or there's more. There's an A in here, a small little A, or I could have a little number there. B, let's call this E. Let's call this, X, Y, and Z. So there's a little A in there, a little B in there, a little C. There might be much more than them, but I don't have much room. A little D. I don't even have room for something in there. Put a D there. I can't even get in there, so I'm not bothering. Then let's say there's an I and a J here. Let's do an A, B, C. Let's do an E here, and F and G here. Okay, so there's a bunch of stuff in these things. They could be much more than mine, and you could even have some stuff outside of here, possibly. Let's say there's an L here, whatever. All right, so here's what you got to do. And they ask you if you have C prime union A in parentheses intersect B equals, and they want a set of stuff in it. They want, you know, what letters, what are those small letters that would belong into this set? All right, so for this, to do this problem, here's what I'm asking you to go to. Go to Exam 3, Review A, problem number 1, actually. Problem number 1. And then what you do is you have to do the answer. The answer is going to be, it's going to turn out that it's going to be shade some parts of it, and whatever letters you find inside that shading, after you figure out how to shade it, whatever letters you find inside that shading, that's going to be the answer. So there's going to be letters inside. You're going to actually choose a set of letters as your final answer. Your final answer will have a set of letters in it. But go to this exam and you'll see how to shade exactly this. Happens to be the same exact problem as far as shading is concerned, but after you shade it, you got to figure out what letters belong in that shade. And that's the final answer that they'll want. That's problem number 9. Okay, problem number 10. Let me pick this up. I actually have room because it's another go-to problem. A lot of them are go-to because we've basically done a lot of this on the previous reviews. A lot of things that are you needed for the final have already on previous reviews. So let's say the problem number 10 looks a little bit like this. Let's say the choice that you can have, and let's say you can have the choice is, let's say, the size, and then it'll say possibilities. If it's this this type of problem, size, and let's say you could have the small, the large, and the jumbo, right? And then they'll say, are you interested in a side dish? Are you interested in a bun for your sandwich? Are you interested in a drink, right? So you get all of this stuff. So how many possibilities are there? How many possibilities are, and that's going to be the question, how many possibilities are there? How many things can happen are there? And this is the multiplication principle. Turns out to be the multiplication principle. And go see, for a problem like this, go to Exam 2, Review D, problem number 13. Go do that problem, and you'll have been practiced. You'll get ready for a problem like this. Okay, problem 10 is done. We run out of paper. Say no. Go here. Get a new piece of paper, and let's go on to problem number 11. Here we go. All right, that's back to the normal curve, the standard normal curve. So A, find area under standard normal curve. Okay, it's not worth it. Let me put this on the next, instead of rushing this, let me put this on the next video, 11. Let's just get out of here. Try to do as least harm as possible. Here we go.